Yes.
Perfect. Thank you. Thank you, Nico. And also thank you, Peter, for the brilliant overview of ASAM in general. So for people who don't know me, I'm SKhastgir, Head of Verification and Validation for Connected Autonomous Vehicles at WMG, University of Warwick in the UK. But in the ASAM world, I had the pleasure and honor of leading the ASAM OpenODD concept project. So I'm going to speak today in my capacity as the project lead for ASAM OpenODD concept project. For this section of the webinar today, we're going to talk about why we actually wanted to do ASAM OpenODD, the reasoning behind it, and then together with Nico, we'll go about some of the introduction of the concept paper structure before we go into the individual crux of the concept paper itself. We've got Jason and Eddie and Bernard presenting the individual concepts. So we'll start off with what we're going to talk about in this session. So we're going to talk about why we initially thought of doing this whole project. Why do we think ODD is important? What are the different considerations that we need to have when we are actually talking about ODD definition? We'll talk a bit about the testing continuum when it comes to the whole simulation-based testing pipeline and how ASAM OpenODD as a single concept fits into the wider suite of ASAM OpenX standards. And we'll talk a bit about how we came about to today. So today is 11th of November. It's been an exciting 14 months, and today is a culmination of those 14 months. So when we started and the entire timeline that we had for ASAM OpenODD concept project. So if you start off with the motivation itself, a lot of you would be very familiar with the 11 billion mile challenge problem. Depending upon how you read that paper from Rand Corporation, it might be 265 million or 9 billion. Essentially, what we're trying to say here is it's a large number. And it's not feasible or reasonable to actually try and drive those number of miles on real world testing. So simulation will play a role. But a very less appreciated number in this whole world of numbers is this concept of if we can somehow establish that we've got an X percentage benefit with AVs from connected autonomous vehicles from human as compared to a human driven vehicle, we can still save X number of lives over the next many years. So what this number is, if you try and somehow establish that connected autonomous vehicles can be 10% safer, and we're not even talking about perfect safety here or absolute safety. We're just saying 10% better than human drivers. Over the next 30 years, we can save 100,000 lives. Now, that's a very big motivation to somehow not only introduce this technology, but also to somehow objectify the benefit. And the whole ASAM OpenX suite of standards is actually towards how do you go about objectifying this safety metric. And ASAM OpenODD is just one of those standards. But given that we are talking about objectification, we've already established that we're not going to drive 11 billion miles. I think to this audience, it's very obvious that we're going to do scenario-based testing. However, another very less appreciated aspect in this whole scenario-based testing framework is not all scenarios are equal. So if you want to deploy your automated driving system in, let's say, central London, the types of scenarios that you will experience in central London are very different from the types of scenarios you'll experience in, let's say, Phoenix, Arizona. So somehow, just saying that we are going to not do 11 billion miles and we're going to do scenario-based testing is not enough. What we need to do is somehow establish the link between the scenarios and where we are going to deploy. So essentially the operating conditions in which we're going to deploy. So the scenario-based testing or the scenario generation process needs to be a function of the operational design domain. And this is a very simple example, but if you look at a slightly more complicated, I won't say complicated, but slightly more non-trivial example. So here in front of you, you see two automated driving systems to a naked eye. However, actually, these are the same automated driving systems. This is a low-speed automated driving system developed by one of the UK manufacturers. One of them is to be deployed in a city center, and the other one is to be deployed on the air side of an airport, so as a baggage dolly. The control system on them more or less similar, but the operating conditions of the two systems are very different. So the types of scenarios that you will use in either of them would be very different. So here you're looking at all sorts of pedestrian and actors. Here you're looking at very different type of pedestrians or different types of actors. So essentially what we're trying to say here is not only is scenario-based testing important, but making scenarios as a function of your operational design domain is key. And because of that aspect, defining operational design domain is very important for us and defining that in an objective manner. And that's one of the big motivations for us when it comes to an ASAM OpenODD project. So we've got our open scenario and open drive that I think a lot of you would be familiar with, but we need something that we need to hinge those standards with. So let's take a step forward in this whole pipeline. So given, I'm assuming right now, all of you are already sold by the fact that scenario-based testing is needed and will be done. That's a given that for this forum right now, given what I've already said. Now, different applications will have different types of scenarios. So you might end up with thousands and thousands of scenarios. So there's another concept that we've as a community, the automated driving system community has been looking at as scenario databases. So next week we've got the open labels standard webinar, which will talk a bit about the databases also. But what we wanted to show here is, if you've got a scenario database which has got thousands and thousands of scenarios, you need an efficient way of actually extracting scenarios that are relevant to you. Now, given that we've just said that the scenarios need to be a function of your operational design domain or your ODD, what you could do if you were clever and want an efficient process is to actually use the ODD labels or ODD attributes as a way to search the database itself. So for example, here I have three different use cases for three different automated driving systems. One is a city center use case, another one is a motorway use case, and the other one is IC non-divided very rural use case. So what we could do is, if I want scenarios that are relevant for this use case, I could search the database with ODD labels or ODD attributes like pedestrian, cyclists, passenger cars, shared pathways, and then I would get only the scenarios that are relevant to you. So that makes us gives us another very important reason of trying to objectively define ODD so that it makes our life of scenario extraction from a database much easier. So that's another motivation. So I'm just giving you more and more reasons why we need to do ASAM OpenODD. But let's think of it from a more engineering perspective. Let's think of it, if I'm a simulation engineer or I'm a safety engineer trying to implement the safety assurance process. So why would I need ODD, or why would I need an ODD definition? So one of the things that we've been doing, as I've been very fortunate to be part of a piece of work that we did for the World Economic Forum as part of the Safe Drive initiative. And one of the things we said within that piece of work was, when you start your scenario generation process, as we said, you start with understanding where you're going to deploy. And where you're going to deploy the location, you can use the ODD taxonomy to define the location. But you can also do is, on top of defining the ODD definition, you can define what type of behaviors do you expect your automated driving system to display. For example, I want cut in, cut out, I want unprotected left turn or unprotected right turn, depending upon which part of the world you are in. And those are the kinds of behaviors you specify that I want from my automated driving system. So the ODD definition, together with the behaviors that you want, can be used to define the first level of scenarios that you need to use as part of your safety assurance process or as part of your scenario-based testing process. So essentially, doing the defining the ODD enables you to define the scenarios if you combine it with the behavior competencies or behavior library that you might already have. So this is a way to actually go from a formal ODD definition, possibly through an ASAM OpenODD standard or a concept, and then go to, let's say, a scenario definition in open scenario 1 or open scenario 2.0. So that's what we're trying to get to here. Ultimately, our aim is to somehow prove that these systems are safe. So therein, there's a lot of work that is happening in Assam and also internationally on how to make a claim for completeness using the scenario library or the scenario database, as well as the ODD definition, because the claim for completeness will come from both of them being compared to each other. So those are the things that why we felt ASAM OpenODD needed to be done, because as of now, as of maybe end of tomorrow, there has not been any language using which we can define an ODD. There are taxonomies which provide you with attributes that you could use to define an ODD, but there is no set language or no standard language that allows me as an engineer or allows me as a regulator to define the ODD. So that's one of the many reasons that we've come up with this ASAM OpenODD concept. So before we go into the different considerations that we have, I think it is very, very important for us as a group, and we in the ASAM OpenODD concept project spent a lot of time trying to understand ODD and what is an ODD, and more importantly, what is not an ODD. And we'll come to that in a later session where we're talking about the technical concepts associated with an ODD. So essentially, I don't want you to read the whole definition here. What is an ODD? We are going back to the people who actually defined the definition or created the definition for ODD, SAEJ 3016. What I want you to focus on here is the first two letters, which says it is operating conditions. So we're talking about operating conditions. Anything that we can say is an operating condition could be or should be part of an ODD. So based on that principle, work that has happened across the world. One of the pieces of work that we did in the UK and had the pleasure of leading was the BSI PASS 1883 that created a taxonomy or a set of attributes for defining an ODD. It's important that I highlight that this is a taxonomy and a set of attributes, and it is not a language. And that is what was lacking when we started ASAM OpenODD. We had this taxonomy, we had some other taxonomies, but we did not have a language. So we wanted to create a language that would use this taxonomy or use these attributes to help us define an ODD definition for a system, or from a developer's perspective or from a regulator's perspective. Another very important aspect that when you're defining an ODD is this concept of ODD attribute awareness. So one of the things that we talk about when we are defining an ODD is if you are crossing your ODD, you are unsafe, or if you're crossing your ODD, you should be performing the minimal risk maneuver, or you should be handing control over back to the safety driver, depending on what kind of system you have. Hello? Hello, am I audible?
Yes, please continue.
Okay, perfect. So one of the things that is very important when you're trying to define an ODD is somehow implement a mechanism that makes you aware of what you have defined in real time. So I'll take an example of rainfall here. So I might say as a manufacturer or as a ADS developer that I can handle light rain, but I can't handle heavy rain. Now, the classic case over here, as an engineer, I would ask, what do you mean by light rain? Or what do you mean by heavy rain? How do I measure that as an ADS developer? And can I only use onboard sensing, or can I use offboard sensing also to provide me that information? Will I get a number as a concrete number, or will there be uncertainty in the measurement also? So any of you who are familiar with measurements or work in the field of measurements would know that every measurement that you do always has a level of uncertainty associated with it. Now, if I want to measure each attribute because I want to be aware of the ODD of my current ODD attributes, then does that mean that there's a level of uncertainty associated with every measurement that I'm doing? And if it does, how does that reflect in the language that we are using to define an ODD? Because then we need to somehow capture that within the language that we're doing. Because ultimately, the ODD definition, which might include uncertainty, has to be a binary thing. You are either inside your ODD or you are outside your ODD. You cannot be 20% inside your ODD and 80% outside your ODD. That doesn't make sense. That doesn't work that way. The whole concept doesn't work that way. So somehow we needed to incorporate these discussions within the language itself. And for those of you who want to know a bit more about the ODD as a concept, I wrote a blog last year. If you're interested, have a read through it. And if you have questions around this particular aspect, happy to answer. But this is a fairly nuanced concept. We will talk a bit about this during the uncertainty session, which Eddie would be talking about. And also, I think Bernard might mention a bit in the metrics side of things. So those are the reasons that we did ASAM OpenODD, but which also allowed us to highlight some of the gaps in the understanding of ODD in the industry right now. And we've tried to address that also with the concept paper, that it's not just talking about the language that we're using, but it's also talking about what exactly is an ODD and what should be included within the ODD definition. So there's quite a bit of work that we did in ensuring all of us have a common understanding in this area. One important thing is ASAM is a standardization body. It's not the only standardization body. It's a very important standardization body, but there are other standardization bodies also who are doing activities in related areas. Now, one of the things that ASAM has a philosophy of, and I applaud them for that, is not to create competing standards. So if there's something that is happening somewhere else, let's make sure we work with them and align with any of the activities that are happening there. That's one of the reasons why we did not try to create a taxonomy of our own. We used taxonomies that for ODD that were already out there, like the BSI PAS 1883 or the SAE AVSC lexicon or the ISO 34503. So it was very important for us to leverage on existing activities that are out there, which also meant that we needed to establish if there was a common understanding of what is an ODD. If not, then we needed to address that. But B, it also enabled us to create some collaborations across these groups. So that was very important for us because ODD as a concept has garnered international interest on various fronts because of its fundamental nature in the safety assurance process of automated driving systems. So that's something that we've done. We've been very fortunate that the project team members for ASAM OpenODD were very active in all other standardization bodies also, and also even regulatory bodies like UNEC, VMAN, and FRAV. Quite a few of us are active in SAE and ISO also. So we leveraged a lot on their expertise and experience and in those discussions. So given all that I hope I have convinced you that doing ASAM OpenODD was a good idea for all the reasons that I've mentioned. I'll briefly mention about some of the objectives based on those reasons and the basic structure of the project. So if you think of the safety assurance pipeline or safety assurance process, there are essentially only three things that you need. You need a set of scenarios, you need a test environment, and you need somehow to use your safety evidence to make an argument that your system is safe. That's the only three things you need. No matter how simple or how complex your automated driving system might be, those are the only three things you need. So your test environment might end up being a simulation platform or a PC-based simulation or test track or real-world testing. It doesn't matter. Each of them is just a test platform. So from a 40,000 feet view, you only need these three things. So what does that mean in the ASAM world? So if you try and dig a bit deeper as to what those three things actually do, or how would you use those three things? So in a scenario world, you will somehow need to create scenarios. So that's the create bit. You will somehow need to format those scenarios in a language, and you will somehow need to store them in a scenario database. And then you will plan and execute that in a test environment, be it simulation, be it real world testing, be it a test track testing. And then you'll finally make a decision if your system is safe or not. Our focus up until now has been in this scenario space of this continuum. I think in future, we as a community and as experts in the ASAM world, we might start entering into the other forums also, but our focus up until now has, especially me personally, has been in this area. Now, but this area itself is very busy area. So when we talk about creating scenarios, I've already established that ODD is a key input to creating scenarios. The scenarios need to be a function of ODD. So somehow the scenario generation process here needs to use the output of OpenODD, which would be a language defining the ODD, to create scenarios and then format them in Open Scenario and Open Drive. And then when you're storing them in a database, use Open Label. So these three are all standards. OpenODD, we've just done a concept project. We hope to do a standardization project. We'll come to that in a minute. So that's how you see that OpenODD essentially is the entry point for the entire safety assurance pipeline that you have for an automated driving system. So with that in mind, we as a group initially thought that it is a good idea to do OpenODD. So we started off in September of last year, September 2020, and we had 4 or 5 phases in the project itself. We had the initial ideation phase, then we had where we were essentially we were diverging. Everybody had their own way of thinking of ODD and what's a scenario and behaviors, etc., etc. So we let that happen because it was very important that we get the whole group at the same level of understanding before we start looking at a language for ODD. And then we focused a lot on the convergence phase, as in trying to get the whole group to understand this is an ODD and this is not an ODD. So that was a big milestone for us as a common understanding. And then in July of this year, we started writing all the concept in a formal document that would be released end of tomorrow. It's the OpenODD concept paper. And we last month, all of October, there was a lot of review happening with the project team. And so here we are on 11th of November today. We're releasing a day before the release of the OpenODD concept paper. And we hope to start a standardization project sometime Q1, Q2 next year. We still don't know on exact date, but it would we will have a proposal sometime in Q1 next year. We'll come to that in a minute. But this journey would not have happened. So these 14 months would not have happened without the effort of all the team members of ASAM OpenODD concept project, but also without Nico and Nico Hegedon and his support and the entire ASAM office's support. So a big thank you to the entire project team, to Nico, to Ben, to Dorothy, Peter and Klaus. Thank you for being with us. Thank you for guiding us through this journey. I'm happy to take any questions now, or we can go into the structure, Nico. It's up to you.
So please post the questions in the chat, and we will cover all of them in the Q&A session after the structure presentation.
Okay, so shall we go to the next presentation?
Yes.
Okay.
Yes.
Give me a minute. I'll try and share my.
The next presentation.
Yes. Oh, this is you and me. Okay.
Yes, that looks good.
Perfect.
Yes.
So
perfect. Now full screen.
Yeah, perfect. Thank you. So now what we would like to do is introduce you, now that we've done everything about why we're doing it, introduce you to what we've done. And Nico and I will exchange views on this one. So we'll start off with the introduction of the scope and things that we've done, and then go into the concept paper itself and the structure of the concept paper. And that would be one of the deliverables that you will receive and will be openly accessible to all of you. So I'll start off with the scope and objectives, and then I'll hand over to Nico to talk a bit about this OpenODD structure and the deliverables. So hopefully this moves. Okay, yeah, so I won't go through the figure itself again. You've already know the background, but where does OpenODD fit in terms of that pipeline? So as I said earlier, the test environment could be either simulation or test track or real world. So the aim of ASAM OpenODD at a minimum is to create a format that is capable of representing the defined operational design domain for automated driving systems for a simulation-based testing approach. That's the bare minimum. if we can do for test track and real world testing also, that's an add-on added benefit for us. So what we wanted to do was capable of representing the ODD. What does that mean in terms of the different types of features that we need for a language? So we came up with this figure as a project group as to what we would like to achieve if we had infinite time and infinite resources for ASAM OpenODD. So we created all these features that we would like to have. Obviously, we don't have infinite features and infinite time, infinite resources and infinite time. So we had to pick and select which were the ones that we absolutely would like to do in the first version of the concept paper and the standard. So at the core of the scope of ASAM OpenODD is the ODD specification itself. That would be using the taxonomy and the ontology of the ODD definition. However, there's a big requirement from the safety assurance work that we need to somehow be able to support and define metrics, support and define queries, support and define uncertainties for all the reasons that we've already identified. So metrics, uncertainty, and queries and even exposure probabilities are some things that we have incorporated within the scope of the first version of the OpenODD concept paper and hopefully the standard itself. So the scope itself is not just the green box. The scope is the green box and all the boxes actually. But in the first versions of our work, we've captured the green box, which is the OpenODD ODD specification, the uncertainty, the metrics, the queries, and the exposure. Now, if we want to do all this, we need to somehow structure the project in a way that all of them are happening at the right time. So we split the project into 4 work packages essentially. The first work package was focusing on attributes. As we said earlier, there are quite a few taxonomies that are out there. We wanted to ensure that we've got alignment across all of them, and also with the ongoing ASAM work of ASAM OpenX ontology project. Work package 2 focused mostly on the format and the specification, where work package 3 went into the details of the metrics, and work package 4 started talking about uncertainty. And we've got Jason, who'll be talking about work package 2. We've got Bernard, who's talking about metrics, and Eddie about uncertainty later in the call. So how did the whole workflow happen? So when we were trying to come up with the concept paper, which is our end goal here, what we did was we started off with user stories and then create a set of requirements from those user stories. One of the important aspects over here was the requirements sometimes can be misinterpreted by different people or interpreted differently. So what we did was we created examples for each of those requirements, and we used those examples to illustrate the concept in 2 example syntaxes. And we'll see a bit about this in the next slide. And at the end of the day, we did not capture everything. So we had to still had a few open issues, which we've highlighted in the concept paper. And today we are here with the concept paper itself. So what does that mean in terms of what you will see in the concept paper? So here, let's look at one of the requirements we had. We had a requirement that the language needs to be human readable as well as machine readable. So what we created was, for this requirement, we created a sample use case. And that use case was then illustrated in 2 syntaxes. So here you see a syntax 1, which says keep road equal to motorway. And here you see a more human readable natural language, which is suitable motorway, except and rain, etc. So for every requirement in the concept paper, you will have a requirement, a use case, and the example in 2 different syntaxes. So what we will get as the deliverable of the concept paper is the concept paper itself. Concept project is the concept paper itself with all the requirements illustrated in 2 example syntaxes. But we also have provided you with an ontology web app, which is an online portal where the detailed ODD attributes can be discussed, can be illustrated, and you can also see their ontological relationships. The link to this web app is actually embedded within the concept paper itself. So if you are interested in looking into this also, you can absolutely do that. It's hosted by ASAM at one of their portals. So I'll stop here and I'll hand over to Nico to talk us through the concept paper structure.